Good evening, everybody. So, we have completed the non uniform flow one part, which is gradually varied flow. So, in the gradually varied flow, I have taken you slowly towards the gradually varied flow equation, then gradually varied flow equation applicable to wide rectangular channels. Then I have taken classification of channel bottom slopes. Then I explained what is backwater curve, what is drawdown curve. Then I have taken to you what are the water surface profiles, what is mean by M curves, S curves, C curves, H curves, A curves. Then I have taken to you how to calculate the length of the water surface profile. So these are the various topics that I have dealt and then followed by problems. So that we have completed one part. So total lectures in this particular rapidly varied flow are 4 lectures. Lecture 1 is rapidly varied flow, hydraulic jump, and general equation of hydraulic jump. Lecture 2 is the equation of hydraulic jump in case of rectangular channels. Equation 3 is energy loss and length of the jump, and basically applications of hydraulic jump. With that, the theory part is closed. The last part is we will take it up the problems, 4 lectures. So let us go into the first lecture, right? So therefore, y1 is called initial depth, y2 is called sequent depth. These two depths together are called conjugate depths. Conjugate depths are formed only in case of hydraulic jump. Conjugate depths means specific force same. Now we are working on this specific force, what it is. That is what is our next aim. Suppose if I take it A1, V1 and Z1 bar represents area of flow section, velocity, and distance of centroid. Distance of centroid or center of gravity from free surface. Then at section 1, suppose section 1 again recollect, this is section 1 we have drawn. So this is the depth of flow y1 and its area of flow section is a1. The velocity is v1 and z1 means actually if I take it, this is z1 bar, distance of center of gravity. Similarly, a2, v2, z2 bar represents area of flow section, velocity, and distance of centroid from free surface. At section 2, suppose if you take it, this is what it is. So this is y2, z2 bar, a2, v2 velocity. So this is. So now for deriving the equations, The external forces acting on the mass of water between section 1 and section 2, between section 1 and section 2 basically are the only thing is hydrostatic force, right? We have assumed this frictional force negligible because forces I am writing hydrostatic forces, frictional forces negligible. Third one is the weight component. This is also negligible. So when these are all removed, the only force is hydrostatic force. Then basically according to because hydraulic jump equation is always obtained using momentum equation. According to momentum equation, basically, if I do it, the hydrostatic pressure at section 1 and section 2 is equal to rho q, right? Mass of water into final velocity minus initial. Right? This is what we call it as net force is equal to change in momentum. Change in momentum per second. This is what the equation is. So what is P2 is equal to gamma into A2 into Z2 bar minus gamma into A1 into Z1 bar is equal to rho means gamma by G into Q into then V1 minus V2. This is what we can write. Right? Then if I expand it, gamma into A2 Z2 bar minus gamma A1 Z1 bar is equal to gamma by G into Q into V is equal to Q by A1 minus Q by A2. Right? Gamma cancel. If I do it, it is A2 Z2 bar minus A1 Z1 bar is equal to Q by G into q square by g into 1 by a1 minus 1 by a2. A little bit again I will do a2 z2 bar minus a1 z1 bar is equal to q square by ga1 minus q square by ga2. So all twos on one side and one on the other side. If I take it this, if I bring it basically the a2 z2 bar plus q square by ga2 is equal to a1 z1 bar plus q square by ga1, right? So finally equation is q square by ga2 plus a2 z2 bar on the left hand side is equal to q square by ga1 plus a1 z1 bar. This is the general equation. Hydraulic jump. Then what is specific force? What is specific force? Specific force F is equal to q square by ga plus az bar. This is what specific force means. This is what is the equation for specific force. So if I take it, this is F2, this is F1. Basically, F1 and F2 are same actually. So the general equation is F1 is equal to F2 specific force at section. This is the so F1 is equal to F2 basically. So this is the now basically this is the general equation. So right using now what we will do in this equation is using this gen equation. If Q y1 are given, we can calculate. Right. Now here I want to, before taking it to the next topic, I want to tell you something. There are two things which we learned actually. Specific energy. Once again, I am bringing here. The other one is specific force. Right? Specific energy is represented by E is equal to y plus v squared by 2g. Specific force is equal to q squared by ga plus az bar. This is the first thing that you should understand. Then next similarities I am talking about, right? At minimum specific energy, the depth of flow is critical depth. Similarly, at minimum specific force, at minimum specific force, depth of flow is critical depth. Third point, except at critical depth, for any specific energy, there will be two depths of flow. Y1, Y2, where specific energy is same. Similarly, here also, except at critical depth, for any specific force, there will be two depths of flow. Y1, Y2, where specific force is constant. These two depths of flow are called alternate depths. These two depths of flow are called conjugate depths. Last point conclusion is alternate depths means E is constant. Conjugate depths means F is constant. So these are all the important points which I want you to stress upon. So finally, what we have concluded in this lecture basically is what we have concluded in this lecture is I have covered excellent bits in this. First thing is after talking about rapidly varied flow and hydraulic jump, when a supercritical flow meets a subcritical flow, hydraulic jump forms. And hydraulic jump equation is derived from impulse momentum equation. That is the important point. Next, generally, there are three forces considered: hydrostatic force, frictional force, weight component. Only hydrostatic force is there. Remaining through two are negligible, that we stated in assumptions. Then what is the final equation of hydraulic jump? General equation is q square by ag at section 1 plus az bar at section 1 is equal to q square by ag plus az bar at section 2. That is what the general equation for hydraulic jump, general equation for rapidly varied flow. Both are same. This is what I concluded. But interesting point at the end of the lecture I mentioned, there is some correlations between specific energy and specific force, because this is very important. Specific energy means it is y plus v squared by 2g. What is specific force? It is q square by ag plus az bar. So this is first thing. Second thing, at minimum specific energy, the depth of flow is critical depth. At minimum specific force, the depth of flow is critical depth. Third point, except at the minimum specific energy, for any specific energy, there will be two depths of flow. One is above critical depth, one is below critical depth, and these y1 and y2 are called alternate depths. Similarly, in specific force, except at minimum specific energy, for any other specific energy, specific force, I'm sorry, for any other specific force, there will be two depths of flow, one above the critical depth, one below the critical depth, and these two depths of flow are called conjugate depths. And conjugate depths are again called as initial depth, sequent depth. Initial depth, sequent depth. This is one of the important points you should remember. Again, for alternate depths, specific energy is constant. For conjugate depths, specific force is constant. Alternate depths are related to specific energy. Conjugate depths are related to hydraulic jump, that is related to specific force. That concludes this lecture actually. Thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.